Hello! Today I would like to talk about a game development topic, namely FOV and aspect ratio scaling in Unreal Engine. Now, it has come to me that Unreal's position and Epic's position on default FOV scaling is rather controversial. So by default, Epic is, or rather Unreal Engine is using something that is colloquially referred to as vert minus scaling method. Epic, or the Unreal Engine itself, refers to it as maintaining X FOV or fixing X FOV. Both of these things refer to the same thing. What happens is that when you have something like 16:9 aspect ratio, as you can see in the debug screen over here, I have a viewport whose aspect ratio is roughly 1.77 repeating, which is the aspect ratio for 16:9. You get the aspect ratio by just dividing those two numbers. Dividing width by height. Now, as you can see, I have set up a little bit of actual measurement of the angles, and also I use just mathematical equations to calculate the various FOVs. So currently, and by default, when you start the first person template, the camera's FOV, and I think it's any camera that you by default create, the FOV is set to 90. Now the question is, what kind of FOV are you setting here? Because the camera does not specify it, like the name of the function is just set FOV. So when you have maintain X FOV, the FOV you're actually setting, you're fixing it in place, is the horizontal FOV. Because it's the FOV along the angle along the x-axis. So currently I have the horizontal FOV set to 90, and that is not going to change regardless of how I change the aspect ratio. The horizontal FOV will always be 90. What is going to change then, the variable in the equation, is going to be the vertical FOV, so which I calculate over here. Currently with 1.77 aspect ratio, which is the 16:9, the vertical FOV comes out to 58.6 when you plug it into the equation. Using the measuring method, by just casting these various rays that describe the frustum, I get that the horizontal FOV is 90, which is the value that I set it to, and the vertical FOV is 50.69, which is roughly, those two numbers should be always equal, but it's just two different methods of getting to them. So if I now change the position, I have created a second character in this demonstration. You can see these rays that I used to calculate the angle, the FOV angles, and this is basically the frustum. This is the field of vision you get on this character. So if I were to do something like zoom in, and basically how you zoom in is you change the fixed FOV, which is in this case, in this default scaling methods case, the horizontal FOV. So I've reduced the horizontal FOV to 10 degrees, and accordingly the vertical FOV has been reduced with it to 5. So now you can see that the viewing frustum, the field of view, is far tighter and is basically just this, almost a cube. This is how you implement zooming of any kind, like binoculars or scopes. You just implement it by reducing the FOV of the camera, and then you zoom back by just setting it back to this default value of 90. Now what the contention, like this is all fine and well. The problem starts to happen when you get something like ultra-wide monitor. Now something like 20:9 or even 24:10, those monitors have a wider aspect ratio than 16:9, which is roughly 1.7 repeating. Or even there are even wider monitors like 32:9, which is monitor that are two 16:9 monitors next to each other, except it's just one whole monitor. Aspect ratio of those things is all the way up to 3.5, so nearly double. So if I were to expand this to such an extreme use case, what I'm doing right now is basically simulating widening the aspect ratio, and you can see that something weird is happening. Like I'm sort of zooming in for some reason. And you can see progressively less of the gun and progressively less of the sky until it almost disappeared when I reach here, which is around a 3.55 repeating aspect ratio, which is 32:9. Now, what happened here? Like, from what you are possibly looking at, you might infer that you are being punished for because these monitors are expensive. You basically buy these things to get a better experience. And you see less of the scene, right? Like you see less of the sky, you see less of the gun, but you still see equal to the angle to the sides is still equal. So now if I were to swap positions, you can see this raycast has widened a lot. But, well, rather not. It didn't widen a lot at all. It was crushed. The vertical angle has been reduced. The value, you can see in the top right, the measured horizontal FOV stayed roughly the same. This is just a floating point arrow, but the vertical FOV has been reduced to 31.39. By contrast, with the 16:9 aspect ratio, the value of vertical FOV was 58.65. So it was reduced by quite a lot. So what's happening here is that you see less of the scene. Like, just numerically, you have less of a viewing angle. Like, you have been basically punished for buying a more expensive monitor. Now, there is a way to remedy this by changing your FOV. Like, so if you get like something like Fortnite or whatever, an Unreal Engine game, and you have an ultrawide monitor, and this setting has not been changed by the game developers, what you can do is change the FOV setting that usually, or rather games should allow you to change the FOV setting. So to get back to the vertical FOV we had before, which is around 15.65, you would have to go to somewhere around here, let's call it 125. Now you can see roughly the same as you could before, like the same of the gun when you had the 16:9 resolution, and roughly equal of the sky, but you see much further to the side. So just switching to the frustum, switching to looking at the rays, you can see that the rays now extend far beyond this cube over here and far beyond all reaching this wall on the left. Now, the horizontal FOV value that I have set here is 125. And the issue is that games usually won't allow you to go that far. Like, usually games cap out at like 90 or something like that. Not exactly sure why. Or rather, I can roughly explain what the thinking is of Epic on this. The reason they would use this scaling method by default anyway, which if I were to set the standard 90 FOV back, the idea is that you get an unfair advantage if you use something like an ultrawide monitor, because you would see further to the sides if you were to set the natural FOV, or rather the horizontal FOV that would correspond to the vertical FOV of the 16:9 aspect ratio. Basically, if you were trying to get the same horizontal FOV, or the same vertical FOV by adjusting the horizontal FOV, you would just simply see far too much to the side, potentially giving you an unfair advantage. That is like the rationale for this thing. Now, insofar as games do not allow you to set the horizontal FOV value that you would need to achieve the same vertical FOV values as you would with just 16:9 resolution, the alternative to all that is just to alter the scaling method. The alternative FOV scaling method is colloquially referred to as horizontal plus. In Unreal Engine, it is referred to as maintaining the Y FOV. And what happens is you basically change the FOV you are fixing in place. So if I were to do that now, and now switch to horizontal plus. You can see that the output that I set up here has changed to set y FOV. Now I'm setting the horizontal or the vertical FOV. That is now fixed in place, regardless of the aspect ratio. And you can see that the horizontal FOV has been greatly increased. This is the FOV that is going to be changing now as we change the aspect ratio. So right now it's at 148 to correspond to the aspect ratio of 3.5 and vertical FOV of 90, because the value hasn't changed. You still have the 90 value for the FOV set, even though you changed which FOV you're actually fixing in place. So now if I were to reduce it to the roughly previous value, I would go down to something like 60. So now we have set the vertical FOV value that was roughly that it was when I had the 16:9 aspect ratio, but the horizontal FOV has been widened still. So the reason the scaling method is called horizontal plus is that it doesn't punish players with wider aspect ratios. You simply, by default, without fiddling with the FOV value at all, you simply just see more, because it is the horizontal FOV that changes, and the vertical FOV is the one that is fixed, compared to the previous scaling method, where the vertical FOV was the one that is the horizontal FOV was the one that is fixed, and the vertical had changed. And the only way it could have changed when you widen the monitor is to reduce it. That's why it's called vert minus, because you're reducing the vertical FOV. With horizontal FOV, you're just expanding horizontal FOV. That's what the horizontal plus. Now, technically, in both of these cases, you could achieve roughly the same horizontal FOV and roughly the same vertical FOV. Even with both those scaling methods. Like, it's not mathematically impossible, it's not even possible within the context of Unreal Engine. The problem is that games, like I said, usually cap the amount of FOV you can actually set. So when the value of the FOV goes only up to 90, then in case of vertical FOV, that's fine. Because generally, even if I go something to like 90 FOV, you can see that the screen starts to sort of, it's sort of getting distorted. Usually, the vertical FOV that you want to use is around 60. That is sort of the natural standard that your people are generally used to. The problem is that the horizontal FOV values with something like ultra-wide monitors and even super ultra-wide monitors like 32:9, which comes out to roughly 3.5, are way beyond 90, like in this case 128, and the game simply doesn't allow you to set it that high. That's why people generally complain about the scaling method, despite it's not inherently the problem of the scaling method, because you can achieve both the proper FOV values with just fiddling around with the FOV value that is set. In both cases, the FOV value that is fixed, be it horizontal or vertical. The problem is that you're just not allowed to, in terms of absolute values. That's why people generally prefer or expect or demand that the scaling method that is used, that the FOV axis that is fixed, is the vertical one, because that is the one that usually sits at 60 for all aspect ratios, and be it 16:9 or 21:9 or 32:9, or even wider with like 3 monitors. It's basically less of a headache. But again, the consideration of Epic is that this wider view frustum that you get out of this is potentially unfair to people that are only able to achieve the FOV that is set, because if you have the vert minus, if you fix the X FOV axis, and for example the game only allows you to go as far as 90, let's say just for the sake of the argument that is the maximum FOV you're allowed to set in the game settings, then the horizontal FOV won't go beyond that when you use the scaling method. However, if you use something like ultrawide with, let's say for now, the alternative scaling method, and the maximum value you can set on the FOV value, which is in this case the vertical FOV value, is still 90, but you can generally go beyond that, or lower than that. The horizontal FOV value in this specific case of ultrawides with horizontal plus aspect ratio scaling is 128, which is way beyond, or rather beyond, the 90 value that is the limit that is set by, let's say, a hypothetical game. I'm not actually sure what if even Fortnite allows you to change the FOV values. So that's basically the aspect of what Epic would probably describe as unfair advantage, like being able to go beyond the limit, the FOV limit that is set by the game with this scaling method, with the horizontal plus scaling method. That is why their games are generally using the vert minus scaling method, because with that method, you do not give anyone any advantage. You are just punishing them for having wider aspect ratios. Although the phrase not giving an advantage with the scaling method, it's not necessarily strictly accurate, because if you were to have something like a 5:4 aspect ratio, which is a really, really old aspect ratio that was used once before a time, in which the actual aspect ratio was really, really like small, close to 1. If we go all the way something like here, no, that's way too much. Let's say you are roughly around here. Then if you set horizontal FOV to 90, then you are getting advantage the narrower monitor you have. But the advantage you get is that you see more of the gun, so you can see more of the lower vertical bound, and more of the sky, which is more of the upper vertical bound. So you still get the advantage to the other side. So the lower your aspect ratio, the greater your advantage with this aspect ratio scaling method. But I suppose it is less of an advantage that seeing more to the sides. Like seeing more to the sides than seeing more to the up and down is greater comparatively. I guess that is the rationale. And people generally are not happy with this, especially like ultrawide users are not happy with this, because these aspect ratios 5:4 or 4:3 they are not used. Very few monitors actually have these aspect ratios, and generally the wider aspect ratios are in use at least 16:9, which is the sort of mainstream aspect ratio. What happens also though is that the game's window, like pro players or some players of Fortnite and these vert minus restricted games, use actual 4:3 like window sizes. Like they restrict the game's window size to a 4:3 aspect ratio, just to gain the advantage. So that would look something like this. It is a very odd way to play, but I suppose you are given that advantage. Like that is why people play in these aspects. So if you see someone playing in 4:3 resolution, then it's someone that is probably just leveraging the vert minus aspect ratio scaling method with the narrower aspect ratio. So how do you as a game developer, if you are listening, if any game developer is listening to this, how do you alleviate this? Because you might have heard at some point that this is something that can only be switched through configuration files, which is not strictly accurate. You can't do it live like I'm doing right now. If you are a player and you're playing an Unreal Engine game and you want to change this, then there is a config setting that you can change. And if it's not explicitly restricted by the game, then the Unreal Engine should accept it and use the horizontal plus scaling method. I will flash it on the screen to describe it and put link to a description on where that config setting actually is. But now I'm just going to show how to do it in game itself on runtime, so that you can export this to a configuration menu. So you can have the scaling method as a configuration entry somewhere. So let's just do that now. So what I did here is created my own C++ player controller. You cannot do this in Blueprints. So you just have to create a new player controller of your own to actually set this value. And it's easy to set. So all the controller has to do is call the getLocalPlayer function, which is a sort of built-in Unreal Engine class that is actually also something that you can create on your own and set it in the project settings if you need. There is a default local player class that you can configure in the game config settings, I think. But it's not necessary to do for the purposes of this exercise. Overriding the player control, or rather subclassing the player controller, is probably what you want to do. And what you do is just create a set function, setter and getter function. And all you do is just access this property of the local player class, which is called AspectRatioAxisConstraint. And its value is an enumeration, this AspectRatioAxisConstraint. These are all defined, or rather this enumerator is defined in engine types .header. And be sure to just expose both of these functions to the blueprints if you want to use them in blueprints further down the line, which is what I did. So with just these two simple functions, one of this is just getting it, and the other one is setting it. Let's just see what the blueprint will then actually looks like, or what the blueprint looks like in my specific case. So the blueprint function I have created here is very simple. When it is called, it's going to get the controller of the pawn, which should be the controller that you created. You can set, you have to set in the world settings the default player controller to the controller that you created, so that this cast doesn't fail, because by default it's just the standard player controller class. Then you just, depending, or rather what I did is just do a simple toggle function, meaning depending on what the current value of the AR aspect ratio constraint is, I just call the opposing value, which is just these two. It's only x, maintain x-axis FOV or maintain y-axis FOV, and then just set it with calling the function that you created, and then possibly just confirming by getting and setting the local variable that I created in this first-person character, which is by default the blueprint created in the first-person shooter template class. And that's it. You can adopt this to a settings screen or configuration menu somewhere, and you're set. You don't have to bother with the actual config. Possibly what you want to do after you do this is just to write into a config and rewrite the configuration value. So I'm just going to show you how to do that now. All right, so all you need to do is put this bit of code here. Now, firstly, you need to include the gconfig cache ini the header file, just so that you can use this gconfig object, which is a sort of a global Unreal Engine object to access the configuration. You need this macro here, which is used to convert an enum value to a string. I'm going to put this into description. And then all you need to do is just define this the config section where you want to put it in the config, which in this case is just /script/engine.localPlayer. You need to set the value, get the string from the value, and then just set string for the specified config section. This is the name of the key. Then you plug in the actual value, and you use this global object Engine.ini, which is just a global string for the name of the Engine.ini, and then you just call this flush function so that it actually writes the value. And that's it. This particular thing doesn't really work in the Unreal editor. For some reason, it just uses some odd value that I'm not even sure where it loads from. But in the actual production, when you ship it, when you package the project, then it's working fine. So you can use this to set up a FOV configuration menu properly. All right, so that's about all of it. Thanks for watching, and hopefully this was useful to anyone. Bye.